This lesson we're going to learn about solving right triangles and use trigonometry to find unknown sides or angles of a right triangle. Now, very important that you realize a little background here is if you're working with a right triangle, the right triangle is very obvious, and we know that the side opposite that right triangle is called the hypotenuse. Typically, we will label right triangles using ABC, with C being the right angle. So angles are always represented by the capital letters, and then the sides opposite them will be the lowercase letters. So how is trigonometry applied to right triangles? There's a relationship between trig and right triangles, and that is that the sine of an angle, and again this is the Greek letter theta, which kind of stands as a variable that stands for an angle, is opposite over hypotenuse. And the cosine of an angle is adjacent over hypotenuse. The tangent of an angle would be the opposite over the adjacent. Hence the acronym SOHCAHTOA. Sine, opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. So if I give you a right triangle, and let's say its sides are 5, 12. So if you do 5 squared plus 12 squared, you get 169 squared. That is 13. That's a Pythagorean triple. FST students will know that from John Baylor Prep. And if we talk about this and label it angle B, then the sine of angle B would be the opposite side over the hypotenuse, which would be 5 over 13. The cosine of angle B would be the adjacent side over the hypotenuse, which would be 12 over 13. The tangent of angle B would be opposite over adjacent, which would be 5 over 12. If this was angle A, then sine of angle A, opposite over hypotenuse, would be 12/13. Cosine of angle A, adjacent over hypotenuse, would be 5/13. And tangent of angle A is opposite over adjacent, which would be 12 over 5. So using SOHCAHTOA to find the missing side of a right triangle. So if I give you this right triangle, and let's say this angle is 23 degrees, and my hypotenuse is 10. Let's label this ABC again. So then, I need to find all the missing measures. Well, what's missing? Angle A is, and that's always very easy to find. There's 180 degrees in a triangle. We already have a 90-degree angle. So angle A and angle B must have to be 90. So 90 take away 23 would make angle A 67 degrees. I also need to find the length of side B, little b there. So using the angle they give me, using the 23-degree angle, I'm trying to find the opposite side when I know the hypotenuse. So I could say that the sine of 23 degrees would equal b over 10. So to solve for b, I'd multiply both sides by 10. 10 times the sine of 23. Making sure your calculator is in degree mode, would be about 3.9. If I want to find side A, using the 23-degree angle, that's the adjacent side knowing the hypotenuse. So I'd have cosine of 23 degrees is A over 10. Multiply both sides by 10. Those would cancel. 10 times the cosine of 23 is 9.2. Now, those of you know Pythagorean theorem, so what must be true here? It is a right triangle. So 3.9 squared plus 9.2 squared must equal about 100, which is 10 squared. Now we can also find, let's say I give you this triangle and I tell you that this angle is 59 degrees. There's my right angle. Let's say I give you this side to be 11. And I ask you to solve this triangle. Well, I would need to know what angle B is. Well, angle A and angle B again must be 90, so angle B would be 31 degrees. If I wanted to find the hypotenuse, so find C. Again, using the angle they give you, 59 degrees, I have the opposite side. I'm trying to find the hypotenuse. Opposite and hypotenuse would be the sine. So the sine of 59 would be 11 over C. Okay, here's an example where the variable is in the denominator. So I would need to multiply both sides by C, get rid of that fraction, and then divide by the sine of 59 to get C. So I'd be taking 11 divided by the sine of 59 degrees, which would be about 12.8 for side C. And that should be the largest side, which it is. To find side B using the 59 degree angle, I know opposite, trying to find adjacent, I would use tangent. So tangent of 59 would be 11 over B. Variables in the bottom, I'm going to divide. So 11 divided by the tan of 59 gives me 6.6. So that's finding a missing side of the triangle. How do you use SOHCAHTOA to find the measure of an angle of a right triangle? So if I have a right triangle, and let's say I give you these sides, so first of all, I would need to find, I could find the, let's say, angle B. To find angle B, I know I've got two sides here. I know the opposite and the adjacent. Opposite and adjacent is tangent. So therefore, the tangent of angle B would be 5 over 8. Okay, now this is very important. Anytime you're going to be finding an angle measure, you're going to use inverse. So angle B is going to be the tan inverse of 5 over 8. So on your calculator, tan inverse is second tan 5 over 8, which tells me that that angle B would be about 32 degrees. So you're finding an angle, use inverse. If I was going to find angle A, now I still know opposite and adjacent, that's still tangent. Tangent of angle A would be 8 over 5. So angle A is going to be the tan inverse of 8 over 5. Using your calculator, the tan inverse of 8 over 5 would be about 58 degrees, which makes sense because those angles have to add up to be 90 degrees. Now you might ask, how do I find this hypotenuse? Well, I could use trig for that. I could also just use Pythagorean theorem. So if I go c squared equals a squared plus b squared, c squared equals 25 plus 64, c squared would be 89. So c must be the square root of 89, which is 9.4. And then I would have solved the entire triangle there. Always using what they're giving you in the first place. Here's another example. Let's say I've got this triangle, a right triangle. I know this side's 4. Let's say this side would be 11. Let's call that C. and I'm going to solve the rest of this triangle. So let's find angle A. So ask yourself, self, what sides do you know? I know the opposite and the adjacent, that's tangent. So I would write tangent of angle A is equal to 4 over 11. So angle A would be the tan inverse of 4 over 11. Which is about 19.98. We'd round that to 20 degrees, would be angle A. If I wanted to find angle B, I know opposite and adjacent, that'd be tan again. So tangent of angle B would be 11 over 4. So how do you get angle B? Use in tan inverse. So tan inverse of 11 over 4 would be about 70 degrees, which makes sense. Okay, how would you get the hypotenuse? Again, you could use Pythagorean theorem, 4 squared plus 11 squared, c squared. So 4 squared plus 11 squared. 16 plus 121 is 137. So the square root of 137 would be c, which is about 11.7. That'd be the most reasonable way of finding that. If you wanted to use trig, and to do this you'd have to use some of the angles. So if I use angle A, which I found to be 20 degrees, I'm trying to find the hypotenuse, and I know opposite and adjacent. So let's use 11 here. So I would use cosine. So cosine of 20 degrees would be adjacent over hypotenuse. That variable's in the bottom. So 11 divided by the cosine of 20 should give me that same value, about 11.7, and it does, so that checks out. So this is solving triangles using SOHCAHTOA, solving right triangles.